5-7 inverse trig functions, day 1. So if you notice, I have the 3 trig function graphs. And when you talk about inverse trig functions, in order for a function to have an inverse, it has to pass the horizontal line test. So I'm going to draw a horizontal line over all 3 graphs. And you're going to notice that all 3 graphs fail the horizontal line test. Therefore, we're going to restrict the domain so that these 3 trig functions will have an inverse function. So let's start with sine. If I restrict sine from negative pi over 2 to positive pi over 2 only, make it really dark, then this part of the graph will pass the horizontal line test. So now this is going to be my new domain for finding the inverse. For cosine, from 0 to pi, I'm going to restrict my domain for my inverse function, because this is where it'll pass the horizontal line test. And then for tangent, you have to be careful because tangent has vertical asymptotes. Therefore, when I restrict this domain, I can't include negative pi over 2 and positive pi over 2. So parentheses means it's not included. So as far as the unit circle goes, I'm going to show you what that means. So to sum up what we just learned, for inverse trig functions, and this is the symbol that you use, and it means the inverse of, we'll use sine at x, and x is an exact value. When you're looking for the inverse, let's start with sine. Your restricted domain goes from negative pi over 2 to positive pi over 2. So on the unit circle, I'll draw it down here. Here's 0. Here's positive pi over 2. Here's negative pi over 2. So that means we can only look in quadrants 1 and 4 to find the inverse function value. And then for cosine, remember it was from 0 to pi. Here's pi. So that means we can only look in quadrants 1 and 2 when we're finding the exact value of the inverse function. And for tangent, we can look from negative pi over 2 to positive pi over 2, which is quadrants 1 and 4 also, but we can't include, oh, big mistake, sorry. Don't include those 2 radian measures, meaning you can't find the inverse of negative pi over 2, tangent negative pi over 2, because it's undefined. So what I did was I drew the unit circle on the side because we're going to need to know the exact values. And I only drew quadrant 1, and that's the quadrant that you need to learn, and then remember everything repeats. So for example 1, I wrote find the exact value of each expression. So what it's asking for A is basically find the angle who has a sine of 0. But take a note, we're only looking in quadrants 1 and 4 because sines inverse is restricted to negative pi over 2 to positive pi over 2. So if you look and see sine, those are the y-coordinates. The only y-coordinate or angle that has a y-coordinate of 0 is 0. So that's this answer. Okay, let's try another one. Cosine inverse of negative square root of 3 over 2. Okay, this means find the angle who has a cosine. That means the x-coordinate is negative square root of 3 over 2. But we can only look in quadrants 1 and 2 because cosine is restricted for the angles between 0 and pi. And so if you look in quadrant 1, pi over 6 would be our candidate, but we need it to be negative, which means it's going to flip to the second quadrant. And the angle that corresponds to pi over 6 is 5 pi over 6. Okay, C, tangent inverse of 1. What angle has a tangent value of 1, only looking in quadrants 1 and 4, but not including negative pi over 2 and or 2 pi over 2. Now, tangent is a little different because you have to divide to get tangent. If you look in quadrant 1, because it's positive, the only angle, if you divide the y over the x, that would give you 1 is pi over 4. So let's continue with a few more. For D, we're doing sine inverse of negative square root of 3 over 2. That means find the angle whose sine value, y-coordinate, is negative square root of 3 over 2. Remember, we can only look in quadrants 1 and 4 because of sine's restricted domain. And if we were looking in quadrant 1, pi over 3 would be our candidate because that has a y-coordinate, but we need it to be negative. So our answer would be negative pi over 3. E, cosine inverse of square root of 2 over 2. This means find the angle who has a cosine value. That means the x-coordinate is square root of 2 over 2. We can only look in quadrants 1 and 2 because cosine is restricted from 0 to pi. So that candidate would be pi over 4. And then we'll do one more. Tangent inverse negative square root of 3 over 3. Remember, tangent is tricky because you have to divide the y over the x. And we can only look in quadrants 1 and 4 again, not including our two values or angles. Okay, so which angle, let's only look in quadrant 1 first. If I divide the y over the x, would give me square root of 3 over 3. We know it's not pi over 4. Has to be either pi over 6 or pi over 3. Let's try pi over 6. If you divide 1/2 divided by radical 3 over 2, that's 1/2 times the reciprocal. You get 1 over radical 3, which you have to rationalize. And there we go. That's our value. We need it to be negative, so it has to be negative pi over 6.